progress.
Hello everyone, my name is Xinyi Niu, and my project is about studying recognition of emotion from speech. In this project, we are recognition of the emotion categories of the voice data by giving the voice data such as happy, anger, sad, and etc. We use the public voice data emotion data series to do the project. The dataset contains 7 emotion categories with 480 voice data from 4 male actors in 7 different emotions. Emotion has been described physiologically in discrete categories: anger, disgust, fear, happiness, sadness, and surprise. They added neutral to provide the recording of 7 emotion categories, total of 120 utterance per speaker. For example, the anger, who organized the unlimited expense account. Speech is the main media of communication in daily life. It is not only conveys ideas but also express speakers' emotion state. The goal of speech emotion recognition is to recognize human emotion state from speech. Therefore, the research of speech emotion recognition is very necessary. In this project, we have made a speech emotion recognition project. We can recognize the emotion categories of the voice data by giving the voice data such as happy, anger, and sad, etc. We have some. This is our data processing. We extract the MFCC by those steps. The pre-emphasized divides the voice into frames, vendoring, short time, fire, transform, mere filter bank, crystal, analyze, normalization, MFCC, label encoder, supply data side. The code of MFCC and the result we got is in here, in this graphs. We can we use CNN model in our project. CNN does well on learning and classifies the audio. CNN is called convolutional neural network, and the main model structure includes the convolution, pooling, and activation. We will study CNN during the class. We are not going to talk much about the CNN. So this is the convolution layer, pooling layer, active layer, and the bench normalization layer is not the standard configuration of the convolution network, but because it is excellent effect, it not only greatly speed up the convergence rate but also improves the model performance. The model we trained on the training set can be applied to the test data because of promise assumption. Training data and test data are independent and identically described. According to the Zen model, our final model is shown here, and the hierarchical structure and parameter design of our model are shown. The drop-down layer guard against overfitting by randomly setting the weight of the portion of the data to 0, and dense union contains hidden layer tied to the degree of freedom. The model has tried to fit in data. As shown in the figure below, I conduct the following experiments for parameter dropout. Adjust the dropout value in turn, retrain the model to obtain the algorithms of the testing machine, and the experimental records are shown in the figure below. The optimizer is used to update and correlate the network parameters that affect the model training and model output, so that they can approach reach the optimal values, thus minimize or maximize the loss function. We can see from the table that using different optimized, the result is different too. The following figure shows the loss change of the model training under the best parameter. When training for the 17 rounds, the model parameter region converges. The following figure shows the model confusion matrix. Label neutral has the highest occurrence. Through the experience, it is found that adding the appropriate dropout can improve the model performance and increase the accuracy. Select a appropriate optimizer can improve the performance of the model. After feature optimization and model tuning, the accuracy of the final emotion category is as high as 62%. Speech emotion recognition is relatively subjective and difficult for machine learning models. The boundary between some categories is not obvious, which will lead to difficulty in classification and model recognition. And this is my work cited, and that's all. Thank you.
Recording stopped.